chance to learn Section 6.6 properties of kites and trapezoids, would you do it or would you choke? This is Mr. Lane again from OHS High School. This is Section 6.6 about kites and trapezoids. You can read through the objective, the why. Make sure you answer number 5 in your notes and send it to me. A brand new 9 weeks, so might ought to get those points while you can. So let's move on. Alright, right here we got a little quadrilateral family tree. Just shows you how everything is kind of related to one another that we've been talking about. This has been kind of a long chapter for us. We got the quadrilateral right in the middle. Notice that everything we've talked about is a quadrilateral, and then branching from the parallelograms we have the rhombus, the rectangle, and the square, and how they're all related. So just kind of a picture for a summary there of how everything ties together. Alright, so a kite. What is a kite? Quadrilateral with two pairs of consecutive congruent sides. So notice that we've got consecutive congruent sides marked on our little picture there, and that the opposite sides are not congruent. So notice that there's only one tick mark here, two tick marks here, so they're not going to be congruent there. So that is a kite. Yeah, you guys might have flown a kite or two. They look a little bit different now, I think, mostly. But anyways, you recognize the old kite. I think that's how electricity was born. Alright, the first theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. So again, you should know what diagonals are from all the other parallelograms and stuff that we've talked about. I think the rhombus also has diagonals that are perpendicular, but now we're going to have one more quadrilateral, which is the kite, is going to have the diagonals perpendicular. So now you have two. Alright, a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So the pair of opposite angles are going to be the two that are not in between the consecutive congruent sides. So this one, B and D, would not be congruent. It would be C and A, which is going to be congruent. Okay? Alright, let's move on here. It looks like we got a quick example. It says Lucy is framing a kite with wooden drills. She uses 2 drills that measure 18 centimeters and one that measures 30 centimeters and 2 that measure 27 centimeters. To complete the kite, she needs trowel to place along KL. There's KL. She has a trowel that is 36 centimeters long. About how much wood would she have left over after cutting this one? Alright, so looks like we're going to have to figure out the distance of KL here. So I think what we're going to have to do is, well, we know that if this is a kite, we know we got some right angles here. Well, if we got right angles, it looks like we got some triangles involved in this here for us also. Looks like we're going to have some 15 centimeters once we cut that 30 centimeters in half here. So I think we can use the old Pythagorean theorem here to kind of figure out the missing lengths of the triangles here. So let's talk about this first, this top one here for a minute. It looks like the hypotenuse of it is going to be 18 centimeters. So I'm going to put 18 squared is equal to, let's see, I'm going to have the 15 squared for one leg. I'm going to have to find the other leg. So we're just going to call this length x here. So x squared plus 15 squared equals 18 squared. Alright, so 15 squared is 225. Let's go ahead and punch out and see what 18 squared is going to be. So 18 times 18, hit the equals here, is 324. So it looks like we're going to have to subtract the 225 from 324. And that's going to give us 99. So x squared is equal to 99. If I take the square root of that, well, I know that 10 times 10 is 100, so we're really close to 10 on this one. So I'm just going to put 10 right here for this length. And now I think we have another Pythagorean theorem that we're going to have to use to find that bottom length right down here. So let's call it y real quick. And then once I find it, I'll have to have just add x plus y and we'll be good. So it looks like the hypotenuse is 27 this time, so we're going to slap down a 27 squared. We're going to have 15 squared for one leg, and we're going to call the other leg, we're going to call the other leg y squared. So let's go ahead and do some multiplying again. So I know that that's 225 from the last problem I just worked. And then we're going to have to punch out 27 times 27 here. That looks like 729. So I'm going to have to take the square root, or actually I'm going to have to minus the 225. And that's going to be 504 for what y squared will equal. So I'm going to have to take the square root of that, which is about 22.5. Just going to round that up. So the full length of this diagonal is going to be around 32.5 centimeters. So if we had a 36 rule, then once we subtract the 32, that's going to leave us with 3.5 left over for the part of the drill that would be left. So we'd have to cut off about 3.5 then for our kite. Alright, regular geometry students would be doing 3 and 13. iPad, yours should be on your assignment through Lumen Touch already. Alright, PQRS is a kite. Exactly one pair of opposite angles are congruent, and I think we're supposed to find those angles, what they should be. So in any quadrilateral, remember the n minus 2 times 180 would give us that there's 360 degrees in the quadrilateral. So I think what we want to do first here is add the 75 plus the 55 and see what we have left out of that 360. So 130 is taken up already, so 360 minus the 130 would be 230. So we got to divide that in between two different angles, so divide that by 2 would be 115 each for S and Q. So those two would be 115. Alright, in a kite, or in this kite, we've got D, A, B. This here is 54 degrees. We've got C, D, F. Right here is 52 degrees. And we're supposed to find the measure probably each one of these, I'd imagine. So let's see. This is going to be a 27 here, and this one here would have to be a 27 degree. Well, we know that all of these are 90 degrees here. So let's see, 90 plus 52. Let's do that real quick. Would be 142, so that's going to leave 38 degrees left for this. So that means that this is going to be 38 degrees here. This is going to be another 52 then. And then 54 plus 90, what would that be? 144. So that's going to leave a 36 degree angle for this, and a 36 degree angle for this one. So, and that's all the angles that would be in the diagram, so I'm sure that we have it all, unless we needed to add the two angles together here, which would be what, 52 plus 36 would be 88. Alright, so that's all we could possibly find as far as angles were concerned there. Let's move on. I got another quick example here, it looks like. Let's see, this is a kite. No, that is perpendicular, so we're supposed to find all the side lengths. Okay, let's figure that out. Okay, if this is 12 and this is 12, this is a 45 degree right triangle. So that's going to make this, well, all we have to do is multiply that by radical 2 to get the hypotenuse. So these two would be 12 radical 2's. Okay, well, to get this hypotenuse, it looks like we're going to have to use the old Pythagorean again. So we'd have 12 squared plus 20 squared is equal to c squared. So that would be what, 400? And this would be 144. So that would be 544 is equal to c squared. So if we take the radical of both sides, then c would equal, break out a handy dandy calculator, clear that, 544, the square root would be 23.3. Which would be this side also. Alright, there we go. Regular geometry students, looks like a big ton of them there for you. We're going to cruise on here. Now we're talking about trapezoids. So trapezoids, quadrilateral with exactly one pair of parallel sides, the top and the bottom right here in this diagram. The bases are the parallel sides, so AB and DC are the parallel sides. Let's see, the base angles would be ADC and BCD. The legs are AD and BC, and if the legs of the trapezoids are congruent, then it is an isosceles trapezoid. So isosceles trapezoid would be this right here. Might make a note of that. It not seeming to be appearing in the box like it should be. Alright, so our theorems here involved in this. So the trapezoid is an isosceles, then each pair of base angles are congruent. So if we have these marked, then we know that this would be congruent with this. And this one's going to tell us the same information, but it's going to go backwards from that. It says if our base angles are congruent, then we know it's an isosceles trapezoid, which would be this is congruent to this. And the last theorem down here says a trapezoid is isosceles if and only if its diagonals are congruent. So if we have a trapezoid, if the diagonals are congruent, we know it's isosceles trapezoid or vice versa. Alright, here we go. An example. We got this as isosceles. We're supposed to find C, D, and E. Doesn't look like it too hard of a problem. We know that this is going to be congruent, so it's 53 degrees. We know that these are parallel. This is a transversal, so 53 plus what equals 180 is what we're looking for. So I think that would be what, 127 degrees, and then this is going to be the same thing over here, 127 degrees. Alright, we got another isosceles. We just got a trapezoid here, and we're supposed to find the angles. So again, these two are going to add up to equal 180, so I think that's going to have to be a 95 degrees. And these two add up to equal 180, so that's going to be a 68 degrees. Alright, so we got KB here is 21.9. And we've got MF all the way across here is 32.7. We're supposed to find FB. Okay, so we know that the diagonals are congruent. We know the full length of one is 32.7. Now we know from this segment to this segment that it's 21.9. So I'm going to go ahead and subtract that and see the leftover here. So that's going to be what? An 8 point, and that's going to be what? 10. So this part here would be 10.8, which means that this part up here is going to be 10.8 also. So FB will be 10.8. Alright, let's move on real quick. Alright, well, looks like we got a lot left here, so I'm going to have to do 2 videos over this one. So I'm going to go ahead and sign off of this. Mr. Lane signing off. By the way, the secret word will be in the next video, so it'll be a nice and short one, so make sure you pay attention and watch it. Mr. Lane signing off from OHS High School. Have a good day.